And welcome back to Algebra 1. Our goal for today is to continue working with our linear equations and making the graph of their solutions. Over the last couple of days, we've been focusing on method number 3 for graphing our linear equations, which is using the slope and y-intercept of a line by getting our linear equation in that slope-intercept format of y equals mx plus b. The only type we haven't looked at on using slope-intercept form is, what if we're originally given this point-slope format? Can we solve it for y to get down here to the slope-intercept format? Once we're there, we've rearranged. We can use this slope and this y-intercept to help us graph. So one last extra notebook example. Can we take a point-slope version of an equation, rearrange it to y equals mx plus b, and get our graph? All right, so we're given our point slope here of y plus 2 equals negative 2 times x minus 3. Now, a mistake some of us have been making is skipping this first step. When I'm trying to get y equals or function form of this equation, I have to show my first step is removing the parentheses by distributing or expanding on both sides. So I'm taking a 1 here and sharing it to our y plus 2. So 1 times y is still y, and 1 times positive 2 is still positive 2. Over here, this negative 2 has to go both to the x, and then be careful, this negative goes with this 3. So negative 2 times x would give us a negative 2x, and then negative times negative will give us a positive 6. There's a lot of us making sign mistakes here on this second number that's causing us to mess up once we go to solve for y, so be careful. All right, our next step here would be, I want to solve over here for this variable y by removing this plus 2. So we're going to subtract 2 from both sides. So we have y plus 2 minus 2 equals our negative 2x plus 6 minus 2. These are like terms, they can go together. So we end up with y equals a negative 2x plus 4. All right, we now know that this coefficient here in front of x is our slope, so negative 2 over 1, or 2 over negative 1. And this constant term is what's called our y-intercept of our line, which we use the variable b to represent. So it's at 4, or more specifically, the location 0, 4, because it's giving us our location on our y-axis. So up 4, right here. And then now we can use our slope of negative 2 over 1 or 2 over negative 1 to help us get to new places on our line. Since this slope here is negative, remember that means we should have a down the mountain line when we go to graph. So be careful, make sure they match. So down 2, right 1 is one way to move. Down 2 to the right 1, down 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 2 to the right 1. Or you can go up to the left 1, up 2 to the left 1, up 2 to the left 1. And then once I get here, I should be able to connect those points to draw in our linear equation. Now, the reason why we didn't look at these specifically with our slope-intercept form, although it works, right? I'm allowed to do this work. If I'm not asked to use a specific method for graphing, this is always an option. Take whatever format I'm originally given, rearrange it into this y equals mx plus b format, and then use the slope and the y-intercept to help you graph. However, we have an easier way, since this original equation was in what's called point slope. In that format, we know a point. Now, it's not the y-intercept point. It's just a random point on our line. And we know the slope. And just like down here, we know the point and we know a specific point called the y-intercept and the slope. Since we knew those two things, we could graph the whole line. So if I know of any point on the line, it doesn't have to be the y-intercept, and I know the slope, I can go straight to the graph without having to get to y equals mx plus b. So our goal for today is, instead of doing this work of rearranging, can we stay in this point slope format, determine what's the point we know from that format and what's the slope from that format, and use just those two things, just like we've been using slope and y-intercept point. Can we use slope in a random point to help us get our entire graph? So that's our goal for today, using point slope format. We're in our note packet here. Go ahead and fill in your important stuff. Key things I need to keep in mind. For slope intercept, right, I've been stressing for this y equals mx plus b. I've been stressing to get this as a plus sign. In point slope, these are subtractions, so be careful. Once you have your equation in that format with subtracts inside your parentheses, then this number here and this number here create an ordered pair of x comma 1. It's not your y-intercept, but it is a point on the line that we definitely know. And then this number out in front of our parentheses back here is our slope. Using just those two things, our random point, not our y-intercept point, so we can't call it b, it's just x comma 1 of a location on our line, and our slope, we're going to graph our entire line. All right, so let's look at an example. Example number 1. We have the point slope format, are really close to it, of y plus 2 equals negative 2 times x minus 3. So we want to get these this add back to subtract. And the way to do that is sort of undo keep, change, change. So the thing you have to remember is an add and a minus negative are the same thing. So instead of plus in here, I'm going to go y minus negative 2. Now, all that's doing is helping us know that this is our y, the whole thing, negative 2 of our point. So be careful. And then over here, this is already subtract, so we're good. X minus 3. This is x. This guy over here is y. So I got to flip-flop the order here for the ordered pair. Because remember, points are always x comma y. So we have a point. It's at just this 3 and this negative 2. Be careful with your signs. The subtraction here is not part of what I'm identifying. It's just the number behind the subtraction. So 3 comma negative 2 is a point that we know specifically on this line. So I'm going to start there, just like I would normally do with my y-intercept. It's a point I know, so I can go to 3 comma negative 2. So to the right, 3 down 2. Now don't get confused. That's not your slope. It's a point we know. Go to the right 3, go down 2, plot a point in your coordinate plane. Now we're going to start to use our rise up, run out, which is our slope, right? This is our rise over run amount, so be careful. Now this number here in front of our parentheses is the slope. All right, so our slope here is negative 2 over 1 or 2 over negative 1. And without having to rearrange anything here, we can get our whole entire line. So starting now from our random point, we know of 3 comma negative 2. We can drop 2, right? We're coming down the mountain. Drop 2 to the right 1. 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 Or I can rise up 2 to the left 1. 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 And now we have enough points that we can connect and draw in our entire line of solutions. As long as we knew a point on our line and our slope, we can get the entire thing. Let's try another. The hardest part here is getting that undone keep, change, change version of our equation. Then identifying the correct point. Remember, when you go to identify this point, you don't include the subtraction, you just include the thing behind it. So just be careful there. And then what's our slope? And using just those two things, plot your point you know, rise up, run out with the slope to get to new places. All right, so what we're calling, I guess, now your number 2. We wanted to get this to a subtract by undoing keep, change, change. So adding and subtracting a negative are the same thing. So this right here, this whole thing, negative 2, is our y for our ordered pair down here. All right, so we now know in this ordered pair, the y part is a negative 2. Bring down our 5 times. This is already a subtract, so we're good. X minus 1. Again, this 1 is our x. So 1 comma negative 2 is a point we know on our line. It has nothing to do with rising up and running out. It's giving us a specific location in our coordinate plane, which says go to the right 1, down 2, right? That's how we plot from an ordered pair, so be careful. The 5 is our slope. So 5 over 1 or negative 5 over negative 1. That's our ratio that tells us how to rise up and run out from our point that we now know of 1 comma negative 2. So we're going to rise up 5, run out 1. This is positive slope. We should be going up the mountain when we're done graphing here. So up 1, 2, 3, 4, 5 to the right 1. Up 1, 2, 3, 4, 5 to the right 1. All right, I'm out of room going that direction. So now I'm going to go back to my point. I'm going to drop 1, 2, 3, 4, 5 over 1. All right, I'm out of space. I can now use those couple of points to connect with my ruler and draw in our linear equation. All right, you're what we're calling number 3. We did a bonus one to begin with. All right, y minus 2 equals 1/2 times x minus 5. All right, we have subtracts here already. So this 2 and this 5 are our y and our x of our ordered pair down here, x and y. So 5, comma 2. I promise people are going to put 2, comma 5 because of the order of where they're located in the problem. But remember, our ordered pairs always go x value, comma y value. All right, so let's plot our point. This is not a rise up, run out. This is a specific location in our coordinate plane, which is I start at the origin. I go to the right, 1, 2, 3, 4, 5, up 2. All right, that's a point we know. Now, this 1/2 is our slope, which tells us how we can now move to get to new places on our line. So we can rise up 1, run out 2. Rise up 1, run out 2. All right, I'm out of room, so I can also drop 1, go left 2 to get to new places on my line. Down 1, left 2, 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 down 1, left 2. Whew! All right, let's take our ruler, let's connect, let's draw in our linear equation, all of our solutions on forever. All right, number 4. All right, we have the equation. Again, we're calling this number 4 since we did a bonus one to begin with. Y plus 3 equals 2/5 times x plus 8. Oh gosh, we have to get both of these to subtract by undoing keep, change, change. So y minus negative 3. All right, this is our y that goes in our ordered pair down here. So our y value is negative 3. Equals 2/5 x minus negative 8 is the same as plus positive 8. That's our x now. This negative 8 is the x down here. All right, let's plot that point. It's not a rise up, run out. It's just a place in our coordinate plane, which is I go to the left 8, down 3, which is right here in quadrant number 3. All right, 2/5 is our slope. So from here, we can rise up 2, run out 1, 2, 3, 4, 5. Rise up 2, run out 1, 2, 3, 4, 5. Rise up 2, run out 1, 2, 3, 4, 5. Now, I can't use negative 2 or negative 5 because it just doesn't fit. So those are all the points that work for this one. So go ahead and use just those 4 that fit in our coordinate plane to show all of our never-ending solutions that go on forever and ever. All right, that should help you attack your work for today. Be careful when identifying your ordered pairs. They must be x comma y, or take these 2 and flip-flop them for your ordered pair. And make sure you go to the correct location with that starting point, because if you mess up where you put your starting point, it doesn't matter if you do everything else correct, you will have the wrong line. All right, see you guys later.